around it and froze to it because the tree is very cold to the lava. So it freezes. The core of this mold had a big tree sitting in it, and a piece of that looks like this, where we have charcoal still embedded in the lava right in here. And so this is a fairly frequent thing here in Hawaii.
Perhaps the most remarkable lava cooling battle was waged in 1973 by the people of the Icelandic fishing village of Heimaey. As rivers of 2,000-degree lava torched homes and threatened the harbor, the villagers fought back, pumping a total of 35 million cubic feet of seawater onto the fiery flow.
When the lava is quenched and cooled, it's rigid and therefore no longer flowing. So the purpose of the water was to very quickly cool a portion of the lava to protect the harbor.
Seawater cooled the lava up to 100 times faster than air. After a 6-month battle, 210 million cubic feet of molten lava was chilled into harmless rock. Then the flow stopped. The harbor was saved. To the public, lava may be the most familiar volcanic hazard, but volcanoes can also kill without a sound. A volcanic eruption can light up the night, but some volcanic weapons are more subtle, like silent gases. Number 9 on the lethal list, volcanic gases. Sulfur dioxide gas can mix with water in the air and turn to sulfuric acid that falls on buildings and forests as acid rain. One of the most dangerous volcanic gases is the odorless, colorless killer, carbon dioxide. The greatest known incident of death by volcanic CO2 occurred in the African country of Cameroon. Nios is a volcanic crater lake. Almost 700 feet below the surface, a magma chamber continually releases carbon dioxide into the water. On the night of August 21st, 1986, a cloud of carbon dioxide, 3,000 feet wide and just as high, rose to the surface. Being heavier than air, the cloud of death crept down to the villages below, suffocating hundreds while they slept.
Carbon dioxide just escaped from this lake and just moved along, hugging the ground, and silently killed these villagers who were sleeping, about 1,700 people.
In addition to their human death toll, volcanic gases almost snuffed out all complex life on Earth before it began. All complex life today depends on oxygen, but this vital element was not always part of our atmosphere. 2.7 billion years ago, when water covered nearly the entire planet, the sky was a poison cocktail of carbon dioxide and nitrogen. In the seas, microorganisms called cyanobacteria used photosynthesis to absorb carbon dioxide and excrete oxygen as a waste product. This oxygen should have risen to the surface to be absorbed into the atmosphere. But some scientists think that gases from submarine volcanoes, especially hydrogen sulfide, reacted with the oxygen, often forming sulfuric acid. In this way, volcanoes strangled complex life in the cradle. But life got a second chance. 200 million years later, a planetary upheaval literally lifted many of those volcanoes out of the depths as part of the first great expanse of dry land. With fewer undersea volcanoes to trap it, oxygen at last floated free to enrich the atmosphere and kickstart the evolution of multicellular life on land. Released, volcanic gases can be deadly by themselves. But as in a gun, gases under pressure can create devastating explosions and propel lethal projectiles. This is a particular danger with the volcanoes arising from the massive collision of tectonic plates.
Two plates are coming together, two plates of the crust, and one plate, the older plate usually, it's cooler and denser, that tends to sink under the younger and lighter plate.
The lower plate is exposed to the 2,000-degree heat below. Water molecules released from the plate rise, melting the mantle and producing magma less dense than the rock around it.
As rock melts underground, then it forms a fluid, then it begins to move up toward the surface.
That magma rises up and erupts out of the surface as lava. More lava comes up, builds up on top of that, and what we have is a very steep volcano.
Most volcanoes formed in this way are called stratovolcanoes. Piles of ash are covered by lava that is thicker and pastier than the shield volcanoes of Hawaii. The steep cone that forms is the classic image of a volcano, reproduced in papier-mâché at every science fair. But the difference between stratovolcanoes and shields is not just cosmetic. The secret is silica, a mix of oxygen and silicon that's the basis of modern glass. Silica is the primary ingredient of magma. But stratovolcano magma rising through the mantle has more silica than shield volcano magma that formed through the crust.
On shield volcanoes, because the lava is so fluid, the gas escapes and can just bubble out like gas bubbles out of a soda. On stratovolcanoes, the lava is very viscous, and the only way the gas can get out is by physically breaking the particles apart. And this causes the explosions. It's like you have everything trapped, and so the gas has to explode to get out.
Stratovolcanoes hurl pulverized rock and ash into the air. And this can create one of the most dramatic and mysterious volcanic dangers. Number 8, volcanic lightning.
In a volcanic eruption cloud, there are all these particles of ash and rock tumbling around, bumping into one another, and apparently it's possible for there to be charge transfer so that some of them end up being positively charged and other of them end up being negatively charged. I guess kind of like when you rub your hand on a carpet or in a very dry place. And as long as those charges build up and become sufficiently unequal, then there will be lightning when those charges equalize to one another.
Electrical discharges actually flash at the mouths of some volcanoes, then shoot up to mix with the lightning in the debris cloud. Viewed from afar, it's an awesome display of nature's wrath. But venture too close, and the lightning can be the last thing you ever see. Since 1999, 4 tourists on the slopes of Italy's Mount Etna were struck dead, their nervous systems entirely overwhelmed by a savage electrical charge. Despite its sudden violence, volcanic lightning is primarily a danger to those near a volcano's peak. But volcanoes have other weapons that can strike hundreds of miles away. The explosion of a stratovolcano can shatter rock and fire projectiles that can kill on contact. Number 7 on our deadly scale, tephra.
Anything that comes out of the mouth of the volcano that's airborne, we call tephra. Tephra can be as fine as 1/10 of an inch. Tephra can get as large as a small car.
Tephra blocks can be blasted out more than half a mile from an eruptive crater.
I was about a mile away from the main crater of Etna when we saw what looked like an eruption cloud. The volcano just decided to give a little burp and threw out old blocks, old rocks that were not even hot, but they just fell on the heads of tourists who were around this crater. 9 people died that day in just a little book.